Alright guys, so we're taking a look at this solving two-step equations practice that we did in class, and if you need some more help with it, that's what we're taking a look at right now. So let's do that. Okay, so remember, the idea when we are solving an equation, no matter what kind of equation, is we want to isolate the variable, alright? Get it by itself. To do that, we use the inverse operations of what's happening, and we're doing it in reverse order from how you would evaluate it, okay? So what I mean by that is, let's take a look at number one. So if we've got x here, if I put a number in for x, the first thing we do is we would divide by 16, right? Then, once we got that whole number, we'd subtract 1. But when we're solving, we go reverse order and we do the inverse operations, okay? So instead of subtracting by 1 last, we're going to add 1 first, okay? Now, again, the idea is we're trying to get x by itself, which means what we do is we are doing the opposite of what has been done to it, and we're thinking about how to get rid of things. So, subtracting 1, the only way I can get rid of that, I want to make it 0, because when we make things 0, we can get rid of them. So, -1 plus 1 becomes 0. So I get x over 16 plus 0 equals -2 plus 1 is -1. I can drop that 0, and there's a special rule, right, that allows me to do that. We call it the additive identity property of 0, right? Because we have these justifications. We're trying to make sure we understand why we can do what we can do when we solve an equation, okay? And we could add, because of that addition property of equality, which I abbreviate POE, okay? Now, I've created an equivalent equation, haven't I? It's more simple, but it's still got the same answer because I'm only using rules that keep my equality intact. So, we already added 1. Now we're going to times by 16. So, 16, when we times, that's like 16x over 16, right? That becomes 1. So we get 1x equals, and we times 16 on this side using the multiplication property of equality, and we get -16 here. Now we can drop that 1, because remember, the number in front of the x tells us how many x's there are, right? If we had 2x, that's really x plus x. If I have -3x, that's -x minus x minus x. So 1x is just x. So we can drop that to become just x equals -16, okay? And we use that multiplicative property, identity property of 1 to do that, okay? All right, so that's basically all we're doing here, is we're just solving some equations. So I'm just going to work through. There's quite a few problems, but we do, generally we benefit from having a lot of practice. So I'll just kind of talk you through what I'm thinking. So on this right side, that's where my x is. So that's the side I want to deal with. I don't want to add 72 here, okay? Which is a mistake I see a lot of people make. So I've got -8 times x minus 8. First thing I want to do is add 8, right? Remember, in order of operations, we follow PEMDAS, right? Parentheses, exponents, multiply and divide, then add and subtract. But when we're solving, we're using SADMEP. So we're starting generally with add and subtract, then multiply and divide, then exponents and parentheses, okay? So I'm going to add 8 to one side, which means I add 8 to the other side. So I get -64 equals -8x plus 0. That 0 we drop off because of that identity property. So now I've got -8 times x, so I'm going to divide by -8, giving me a positive 8 equals 1x. Then I can drop that 1x and I get 8 equals x. Now, sometimes some people will say that you can't have your answer looking like that, okay? But remember, this is an equal sign. An equal sign means they're the same on either side. So x equals 8 is the same as 8 equals x, okay? That doesn't matter, all right? So then my justifications. So we used the addition property of equality, then the additive identity of 0, we abbreviate, then the division property of equality because we divided both sides, and then finally that multiplicative identity of 1. Okay? And we'll see that we end up using a lot of these similar rules, pretty much. Okay? Now, we take a look at number 3. Now, number 3, you'll say, oh, according to SADMAP, I start with add and subtract, so I subtract 3 first. That is going to be wrong. Okay? And there's a reason for that. The reason is this m plus 3, because it's all on top of the fraction, it's like it's in a parentheses. Parentheses is last. So I work my whole way through, and we actually have a divide here before we deal with that parentheses, okay? So I'm going to multiply by 2 on both sides, okay? Because that 2 is dividing the whole side. So that becomes 2 over 2, which is 1, so 1 times m plus 3 equals 5 times 2 is 10. We use the multiplication property of equality here. Okay. Then we drop the 1 with that multiplicative identity of 1. So we can drop the parentheses once we've got that. Now we'd circle back and we'd start going with what we have. Okay. So m plus 3 equals 10. So we'd subtract 3 from both sides, giving us m plus 0 equals 7, right? Which we drop that and just give us m equals 7. So that was a subtraction property of equality and the additive identity of 0. Okay? And then we get m equals 7 for our answer. Alright? Okay, now number 4, there's 2 different ways you could do it. The first way I would do it is I notice these parentheses and then I'm multiplying by 4. So I'm going to divide both sides by 4. That becomes 1 times n plus 10 equals 112 divided by 4 is 28. Okay, then we drop the 1, so we get n plus 10 equals 28. Then I subtract 10, giving me n plus 0 equals 18, which I drop off the 0 and get n equals 18. So we use the division property of equality. We also use the multiplicative identity of 1, then the subtraction property of equality, and finally that additive identity of 0. Okay? So, there we go with that one, guys. Now, I said that was only one version, one way to do it. So, let me show you the other way we do it. Because a lot of times when we see this, we think, oh, we've got to distribute. And in a lot of cases we do. Some cases we don't, like this one, some we do. So if I distribute, I go 4 times n to get 4n plus 4 times 10, which is 40. Make sure you multiply both, equals 112. Now I use the distribution property, which sometimes it's called the property of addition over multiplication or something weird like that. I just like to call it property of equality because this is equal to this. So now I would subtract by 40 using the subtraction property of equality, giving me 4n plus 0 equals 112 minus 40 would give me some number. For sake of time, I'll just plug it into a calculator. 72. Drop the 0 to get 4n equals 72. Then we divide by 4, giving us again 1n equals 18, which we just dropped the 1, giving us n equals 18. So we use that additive identity of 0, then with the division property of equality, and finally the multiplicative identity of 1. Okay, so often there's more than one ways to do some of these problems, and that's great. Okay, so let's take a look at the next group. So we've got r divided by 4 plus 1 equals 3. Now, up here on number 3, right, we multiplied, okay, by 2 first because the whole thing was divided by 2. Notice the r is simply divided by 4 here. So this plus 1 is what we deal with first. Different situations, different order, okay? So I would subtract 1, because that's the only way I'm going to get rid of that plus 1. So I get r divided by 4 plus 0 equals 2. drop the 0. R divided by 4 equals 2. So we use the subtraction property of equality and the additive identity of 0. Then we times by 4. That becomes 4 over 4, which is 1R, which we turn into R, using that multiplicative identity of 1. 2 times 4 is 8, and so we use the multiplication property of equality, and we get our answer equals 8. Okay, so we're just doing the same type of stuff, positive 7, so I subtract 7 from both sides. Okay, now negative 17 minus 7 gives us negative 24 equals 0 plus 6R. Drop the 0. 6R equals negative 24. Divide by 6. And we get negative 4 equals 1R. Negative 4 equals R. So we use the subtraction property of equality, then the additive identity of 0, then the division property of equality, and finally the multiplicative identity of 1. Okay, so hopefully we're seeing some patterns in what we're doing here, because that's the whole point, is recognizing those patterns and using them. Okay, all right. Negative n plus 4 equals negative 4. Start off by subtracting by 4 using the subtraction property of equality, giving us negative n plus 0 equals negative 4 minus 4 is negative 8. Drop that using the additive identity of 0, giving us negative n equals negative 8. Now, if you're not sure what to do here, remember a negative variable, okay, just like we said, if we have 1n, that's really like just 1n. So if I had negative 1n, that would be a negative 1, so basically I've got a 1 there, right? So negative 1. So I'm going to divide by negative 1, because I want to get to a positive number, okay? So negative 1 over negative 1 is a positive 1n equals negative 8 divided by negative 1 is positive 8. So we get n equals 8. And there's all our justifications. Okay, number 8. We can see different arrangements, different setups, but the same process. We've got n divided by 4 plus 8, so I start by subtracting 8 from both sides. Okay. One big mistake I see is a lot of people try to multiply by this 4 first. Okay. The problem is they just go times 4 times 4 and they get 16 equals n plus 8. Okay. The thing is, if you're going to times first, you got to make sure you get every piece. So I'd go 8 times 4 and get plus 32. And then I would end up solving that and get the same answer. Okay. So you can do it that way. I'm not going to focus on that way, but you can do it that way. So we subtract 8, giving us negative 4 equals n over 4 plus 0. Drop the 0. And we're going to times both sides by 4, giving us negative 16 equals 1n, which then we just drop the 1 to give us n. Now, I could leave my answer like this, and it's still going to work. Okay? There's nothing wrong with that. Then I put in our justifications, which again you can see I'm using basically the same 6 with sometimes that 7th added in of distribution. Okay, this one I didn't remove the 1, so I'm just leaving it like that. I don't need to put that multiplicative identity of 1 in there. Okay. All right, last 2 on this page. Okay, so again, we've got that whole fraction thing going on. So what we want to do is we want to times by 10 first, using that multiplication property of equality, which 10 over 10. Now, you see a lot of teachers do this. They'll cancel it out, okay? And plus, you may be complaining, thinking, oh, why do we have to keep putting these guys on here? Additive identity of 0, multiplicative identity of 1. Can't we just eliminate those? Okay, and yes, eventually you can. But the reason I like to do it now is because I hear a lot of teachers say, oh, we cancel that out. Okay, canceling it out doesn't necessarily tell us what's happening. Because really, what's happening here is this. we're timesing by 10 over 1 because we're multiplying by a fraction. So I go 10, oops, not 12, 10 times m plus 10 over 10 times 1, which is 10. Then we see 10 over 10 becomes 1 times m plus 10. Then we can eliminate that 1 because of the multiplicative identity, and we get to 10. So I fear when you say canceling out, you don't understand why it is that that stuff is canceling out. Okay? Which is why I like to have to put that extra step in there for now. Okay? Because I think it's useful to recognize what is actually going on. Later we'll get to the point where we don't need to, but for now I think it's super useful to understand what is happening in our situation. Same thing right here. A lot of teachers say cancel that out. Well, you don't always recognize that canceling out when you're multiplying means 1. When you're subtracting or adding, it means 0. Okay? I'm going to put subtraction property of equality and additive identity of 0. But because really what's happening, right, is we're going 10 minus 10 equals m plus 10 minus 10. Well, these become 0, right? 10 minus 10 is also 0 in this case. But adding 0 we know does nothing, so we end up with 0 equals m. Okay? Again, I fear that when we say cancel out as teachers, that sometimes a student, you, don't quite understand what's happening. That's why in this case I want you to keep it on there, because I want you to recognize what is going on with this situation. Okay? And I know it's a little tedious, but as you can see, I'm solving each problem along with you, and I'm having to do it as well, so that's okay. Okay? So as we can see, just like everything else, still doing the same justifications because we're just practicing the same type of problems. Okay? Alright, let's jump to the next group. Okay, the next page. So again, we're just solving them the same way. Okay? Just solving them the same way. So I'm just going to kind of go through again. I'm not really going to do a whole lot of talking. Just remember, as you're looking at these, you're always thinking what's happening to the variable. First, I'm timesing by 9. If you need to, write it out. Then I'm subtracting 5, but to solve, I would divide by 9 instead and add 5, and I start from the bottom and go to the top. Okay? And there we go. Okay. The other thing to remember is that as we are solving, we always look to the side where the variable's at. And that's the side that we do stuff to. That's how we choose to do it. The number over here on the other side just ends up being kind of like a bystander that gets caught up in the action and changes, but we never actually deal with it, okay? In the same sense that we deal with the other side where the equation actually is. So in this one, we times by -4 first, using that multiplication property of equality. That would become 1. 1 times 10 plus x. We drop the 1 and the parentheses, 10 plus x. Okay, -4 times -4 gives us positive 16. Then we subtract 10. 16 minus 10 gives us 6 equals 0 plus x. Drop the 0. Oh, and I forgot. This was the multiplicative identity of 1. The subtraction property of equality. And then the additive identity of 0. okay? So, that's all we're doing. 13 and 15 could be done two different ways. I'll show you both ways. So if we did distribution first, we get 133 equals 70 plus 7x. Using distribution property of equality, subtract 70 from both sides, and that would give us what, 63, I think. Yep. Equals 0 plus 7x, so we use the subtraction property of equality. We'll now use the additive identity of 0, and that becomes 63 equals 7x. So I'm going to divide by 7, giving me 9 equals 1x, which is 9 equals x. Okay, so we divide property of equality and the multiplicative identity of 1. Okay, whereas if we look at number 15, because this whole side's together, I could start out dividing by 3, negative 3. That would give me 1 times v minus 3 equals 9 divided by negative 3 is negative 3. So we use the division property of equality first. Then we'll use the multiplicative identity of 1 to get rid of that 1 and the parentheses. Then we add 3 to both sides, giving us v plus 0. Or you could put v minus 0. Negative 3 plus 3 is also 0. And we drop that using the additive identity of 0. And we added 3 using the addition property of equality. Okay? So, yeah. So let's just keep on trucking. Hopefully you've recognized why we start with the numbers that we start with, why we try to get rid of things, and how we are then using that information to help us out. Now, some of these, because they're simple enough, you could just, kind of guess and check and figure out, oh, I know how to get this to be the right number, okay, just by kind of looking at it, and that's okay. But we want to practice these different steps so that when they get harder, we're able to do the steps, when we get beyond the point where we can just guess what they are. Because eventually, you get two equations that would look maybe like this. Okay, a lot harder in that situation to just, guess, because you got 3 different x's in there and a lot more going on, okay? Could you still do it? Yeah, you could still do it, but it'd be harder, take more time, so you're just better off kind of following these steps and really focusing on understanding why we do them, how we make them more simple, and that's the whole process of solving, how we use those inverse operations to do it. And how we come up with our answers, because basically we're just dropping each equation down to the most simplest form till we end up with just a variable equaling a number. And again, that's what we're trying to do here, okay? Alright, so let's just keep on going here. On number 17 now, we take a look at this one, and we're going to add 7 to both sides first, right? Now, if it's helpful, sometimes I've seen some teachers have their students draw a line down the equal sign. If you need to make sure you're doing things on the opposite side of the equal sign, that's great. You can do that. Addition property of equality right here, okay? Giving us negative 3 plus 7 is positive 4 equals m over 4, because we didn't touch that one, and plus 0. Then we use that additive identity of 0, drop the 0, and we are going to multiply both sides by 4, right, to get rid of that fraction, giving us 1m equals 4 times 4 is 16, So use the multiplication property of equality. Then we drop the m because of that multiplicative identity of 1. And there we go. Okay. Now, taking a look at number 18, okay. Now, we can do it two different ways. One of the ways, right, was dividing by 2 first, because 2 is multiplying by the whole thing. That becomes 1 times 1 plus x, which we drop the 1, giving us negative 24 divided by 2 is negative 12. Subtract 1 from both sides, and we get negative 13 equals x. So we did the division property of equality, then multiplicative identity of 1, and we did the subtraction property of equality. And I didn't show it, but we did do that additive identity of 0. Okay, number 19, we've got v minus 1 divided by 3, so the whole thing is divided by 3. So remember, we times by 3 on both sides first. That gives us 1 times v minus 1 equals 2 times 3 is 6. Use the multiplication property of equality. Then we're going to use that multiplicative identity of 1. And we come up with v minus 1 equals 6. Add 1 to both sides, and we get v equals v plus 0 equals 7. Drop the 0, and we get 7. So we use the additive property of equality and then the additive identity of 0. Okay, number 20, 31 equals negative 8n minus 9. Start by adding 9 to both sides using the addition, I should say, property of equality. Negative 8n plus 0 equals 40. Drop the 0, that additive identity of 0. So 40 equals negative 8n. Divide by negative 8. And we get 1n, which then becomes n. So 40 divided by negative 8 gives us negative 5. So we use division property of equality, and then the multiplicative identity of 1. Okay. All right, now we just got, what, 10 more problems here, right? Yep. All right. So let's just keep busting these guys out. Now that's not 9 minus, that's a positive 9, so to make it 0, we have to subtract 9, right? But we keep that negative 10k. Okay, then we're going to subtract 9 to give us negative 20. Okay, so we're using these same things that we've been using. Now that negative stays with the k, it doesn't disappear, so we're going to divide by negative 10k using the division property of equality, and get 1k, because negative over negative is a positive, equals 2. So k equals 2. Using that multiplicative identity of 1. Okay, now we're going to jump down and do 24, just because I feel like it. We'll use distribution this time. So the distributive property of equality. We get negative 12 equals 6 times n minus 24. Add 24 to both sides, giving us positive 12 equals 6n plus 0. Drop the 0. Divide by 6. 2 equals 1n. Drop the 1. We get 2 equals n. And all our rules that we have been dealing with, right? We should be seeing those patterns and what we do, how we react, and all that stuff. Okay, 22. Add 1 to both sides. Drop the 0. Divide by 5. 1b equals negative 3. b equals negative 3. So addition property of equality first. Oops. additive identity second, division property third, and multiplicative identity fourth and last. (26) Add 2 to both sides, giving us 24. Whoop, adding, not subtracting. So 28 equals 2x plus 0. 2x equals 28. Divide by 2. 14 equals 1x. 14 equals x. Add po. Add id of 0. Div po. Mult id of 1. All right, add 9 to both sides. Negative 13 plus 9 would be negative 4. Drop the 0. Times by 3. 1n equals negative 12. N equals negative 12. We ended up using that multiplicative identity of 1 last because we had multiplied both sides using the property of equality. Then we were able to do that because we had the additive identity of 0, remove the 0 that we got when we used the addition property of equality. All right, 27. Now, some of you may just end up doing it like this. And really, I would prefer that, times by negative 2, that we didn't just leave off the stuff for right now. But if that's all you do, and you still can do it correctly, then I guess I'll be okay with that. Then you would just have a lot less to write, wouldn't you? Which I'm sure you guys would really enjoy that. Okay, I would as well, because this is definitely a lot to write, and hopefully it feels tedious because we keep doing the same thing over and over, because you've recognized the patterns and can use them well. All right, last 3 problems. We are almost there, folks. So we times by 6 on both sides here because the 6 is being divided by everything, giving us 9 plus x equals 12. Subtract 9. That becomes 0. We can eliminate 0, and we get x equals 3. Again, if we're just doing it this way and skipping some steps, that's generally all right, as long as you do know what you are doing. It's when we run into people confused as to why we eliminate things. That's when I have issues, and why for this time I wanted you guys doing every piece, just because I think it is helpful to see where every piece is going, why we can get rid of it, why we want to get rid of it, and what means we can get rid of it with those justifications. Last one, I'll do this one twice for you guys to highlight both options.
Sean Kaima.
Okay.
Please meet your mother in the comments. Sean Kaima.
Well, that was awkward. So, first way would be distribution, right? And we'd get negative 40 equals negative 10v plus negative 40. Add 40. Oops. Almost made a mistake there, didn't I? We'd get 0 equals negative 10v plus 0. So 0 equals negative 10v, divide by negative 10, and hopefully it was easy to see that you have 0 for v, which is all right to have. Okay, that's an all right thing to have happen for you because of what is going on in this problem. And we write out all our properties of equality, and that is the first way that we can do this one. The second way would be to divide by negative 10 first, giving us positive 4 equals 1 times v plus 4. So we used division property of equality first. Drop the 1 using the multiplicative identity. Subtract 4, which this changes things because of that being a negative 10. We get 0 equals v plus 0. So we actually used the subtraction property of equality here. Then using, so that's third. Then using the additive identity, we drop it and get v equals 0. All right, guys, so hopefully that's a lot of examples, a lot of things to help you see what's going on, and there we go.